Okay, this is grade 10 again. At the beginning, it's review, so you should have no trouble with it. The first couple of pages are reminders. You could probably just go ahead and do them without me, but I will quickly remind you how to do them. We will very soon be moving on to new stuff to grade 11, but to do that new stuff, you have to be able to do the old stuff. So, all of you should be fairly comfortable with this structure, yes? We've already talked about it in the last unit. A is a coefficient, which means it multiplies. N is the index. We also call that the root. That means that is the size of factor group. And I'm going to explain that in a minute if you don't remember it. And this is what we call our radicand. I will be using those three words as what they are, okay? I will not be calling this the big number under the root sign. I will be calling it the radicand. I will not be calling this the little number that you are looking for root to root. It is the index. I will not call this the big number that timeses everything after it. I will call it the coefficient. So learn what those words mean. Okay? All right. An entire radical. All right. An entire radical. I'm going to highlight that because these are two different things. An entire radical has no coefficient. And a mixed radical has a coefficient. And we remember that coefficients are made up of, these are made from the factors of the radicand. So depending on the factors of the radicand, that will tell you what your coefficient is going to be. Okay? All right. So you guys all should remember how to do this from the 10th grade. If you don't, of course, I will show you. Remember, you can do it with your calculator, but this is grade 11. We do not want decimals. If you punch that into your calculator, you're going to get a decimal. That is useless. You are going to be doing this exactly. To do this, you have to do the product of primes. Now, what do I mean by that? This will work always. There is a shortcut, which I will show you in a minute, but I'm going to show you the long way that always works. So, step 1, 72. There's no index. So what's the index? 2. That means I'm looking for groups of 2 factors. 72 breaks down into 8 and 9, 2 and 4, 2 and 2, 3 and 3. And that gets you 2 cubed times 3 squared. Yes? Now, that means that I am still dealing with the square root of this. I need groups of 2. Is there a group of 2 here? Yes, there's 3 of them, so I can take out one group of 2. So, I bring a 2 out to the front. I took 2 2's out. I am left with 1 2 under there. Is there a group of 2 3's? Yes. Out comes a 3. There is no 3's left under there. These are now both out in front, which means they are both coefficients. What do coefficients do? Multiply. And I get 6 root 2. That is the long way. That will work always, no matter the numbers with which you are working. There are shortcuts. If you are good at memorizing squares and cubes, you can make your life way easier, because the root of 72 is also the square root of 36 times 2, isn't it? And the square root of 36 is what? 6. So I bring out the square root of 36, 6, and I left in there 2. Does everyone remember this from the 10th grade? There are other ways to do this without a calculator. If you have another method, feel free to use it. Okay? But one of these two will get you through. Everybody good? Everyone is good? Okay. Now you will notice that for the first few questions, it's all numbers. Okay? For quite a ways, we're doing all numbers. When we get to page 32-ish, I'm going to do a little bit of work with letters. It is no different. Okay? So, these first couple of ones, I want to do A through G and 2A through D. And then I am going to leave you to the rest. All right? So, root 99, that is 3 times 3 times 11, right? Take out a group of 3, 3 root 11. You can also look at that as the root of 9 times 11. Square root of 9 is 3, out comes the 3. Remember, if you can spot perfect squares, you can make this way easier for yourself. You can also use a mix of the two. If you are doing factoring, like a factor tree, and you get to a square, a perfect square, you can stop there, can't you? So 75, some of you will factor that down. Some of you will recognize that that is 25 times 3. What's the square root of 25? 5. So out comes a 5. What stays under there? The 3. Does everybody remember this? Easy peasy, yeah? Okay. 80, that's a tricky one, because few people are good with their 16 times table. That happens to be 16 times 5. But if you didn't know that, what would you do with 80? Break it down. 4 and 20. You could do. And then so on and so on and so on. 8 and 10, whatever. So that's going to be 4 root 5. What about 300? What am I going to use there? Yeah, I would use 100 times 3. And what's the square root of 100? 10 root 3. Is everybody cool? Okay, 63. This is when I find out who really memorized their times tables in grade 3 with Mrs. Badcrumble. 7 and 9. What's got a square root? The 9. 3 root 7. 32. 8 times 4. 2 times 16 is what I would use, because 16 has a square root. 4 root 2. Right? 163 or 363. Ugh. It's 121 times 3. Why 121? Because it's got a square root. What is it? 11 root 3. Is everybody good? Does it matter how big we make the numbers? No, you follow the same rules. Does it matter what I do with the index? Does it matter what I do with the index? Yeah, the index matters, doesn't it, Michaela? We're going to come to that in a minute. Okay, reverse it. So this is telling me that if there's a 2 out here, how many 2's were under the radical sign? There were 2 of them, yes? So this goes back under there to become the root of 5 times 2 times 2, which is root 20. Everybody cool? Of course, there's a shortcut. 2 root 5. What should the index here be? 2. 2 squared is what goes back under there. Everybody cool? So 7 squared. So what's going back under there? 2 7. So it's 29 times 49. I can't do that in my head. One of you will do that with your calculator and tell me what it is. 1,421. Thank you. What about this one? This one's easy. 4 times 6 squared. 4 times 36. 144. What about this one? Tricky. So tricky. Ooh, so tricky you could put a tail on it and call it a weasel. What's the coefficient here? If there's a -5 out there, that would mean there were 2 -5s under there, wouldn't it? And 2 -5s would get me positive 25, wouldn't it? So this under here must be 25 times 12, yeah? Why didn't I bring a negative under there? But I still have to have a negative, don't I? Because this whole value is negative, isn't it? So I can't bring that negative under there. Why? Is there a negative square root? No, that is undefined. So where does that negative have to live? Out front. It has to be negative root 300. Very tricky and extremely important to pre-calculus 11 that you remember that this doesn't exist. Okay? Does this exist? Cubed root of a negative. Is that okay? Final answer is no. You sure you don't want to call a friend? You don't want to do a shout out the door of the cash cab? Yeah, you probably should. Call Nav.
No, not me. It's yes. I changed my answer to yes.
It is indeed yes. Why?
Because it's
What's the cubed root of -8? -2. -2 times -2 times -2 is -8. Everybody cool? This is okay. Now let's see if you guys can follow basic logic. Is this okay? 4th root of a negative. Yes or no? No. Undefined. That's why it's green. Is this okay? 5th root of a negative. Yes. What's the key? Odd numbered indices can have negatives. Even numbered indices cannot. That's the plural of index. Like the plural of codex is codices. But the plural of platypus is platypuses. The plural of cactus is cacti. But the plural of octopus is octopuses. The plural of rhinoceros is rhinoceroses. The plural of hippopotamus, however, is hippopotamuses. It is not hippopotami, but the plural of fungus is fungi. That's why you should always take a toadstool on a date. Because the toadstool's a fun guy? Shut up. Okay. I just gave you this question on your last little test there to see if you could handle it. It was not done incredibly well. The answer was C. How do you do this? How do you do this without a calculator? Put them under there. This is root 98. This is root 75. This is root 14. This is root 81. This is root 36. Now it's real easy to put them in order. Right? What's the littlest? Root 14. Then we build upwards. Everybody cool? All right. Now that, ladies and gentlemen, should be all that you need to do everything up to page 30. Is page 32 the page with the triangle formula on it? Do not do the triangle formula. Stop at page 31. That is your homework for Tuesday. I know, right? Monday is no school because we have a fake holiday on Monday. Actually, I lie. I'm a big liar. Do 32 as well. Oh, shut it. Fine. 32 is your warm-up. When you get in here on Tuesday morning, class starts at 9:35. By 9:45, I had better see page 32 done. That's why I did 9:45. Yes, Elvin? You do not need to do page 32 until Monday. In class, when you walk in the door. You can, I don't care. Now listen to me, please. Guys, listen up, please. On page 32, at the very top, I'm going to do one last little thing, but not till Monday. I'm going to show you how radicals work with variables. Okay? It's real easy. Everybody cool? All right. Yep.